So we're going to use the formula rate times time equals distance to solve some word problems. And the first type of problem I'm going to solve, you'll see the word apart. And we're going to solve these using one equation, and we're going to be adding distances. So here's an example. We have two trains traveling in opposite directions, and they end up 200 miles apart after 2 hours. One train travels 20 miles an hour faster than the other, and we want to find the speed of each train. So I'm going to start by making a chart, and I'm going to use rate times time equals distance. So we have two trains that are traveling apart. So they start and travel for 2 hours. And after 2 hours, we see they are 200 miles apart. So I know that the distance traveled by this train added to the distance traveled by this train is going to be 200 miles. So to solve this problem, I'm going to add the distance traveled by one train to the distance traveled by the second train and set my equation equal to 200. So we have, we'll call one the slower train and one the faster train. So we're going to, for rate, we'll use R, and if one's going 20 miles an hour faster than the other, we'll say that the slower train is traveling R miles per hour, and the faster train is traveling R plus 20. So clearly this is the faster train because it went farther. And they both traveled for 2 hours. And we're going to multiply rate times time to get the distance. So 2R is the distance the slower train traveled. And 2 times the quantity, R plus 20, is the distance the faster train traveled. And I'm going to use this distance column to set up my equation. So 2R plus 2 times the quantity, R plus 20, is equal to 200. So I'll distribute here. So we're going to have the rate is equal to 40 miles per hour. So if I take that back to the chart, R is 40, and 40 plus 20 is 60. So the slower train goes 40 miles per hour, the faster goes 60 miles per hour. So multiplying here, 40 times 2, the first train went 80 miles, and the second train went 60 times 2 is 120, so that checks because it equals to 200. So sometimes with these apart problems, the trains begin apart and travel towards each other. So if we have two trains and they begin 200 miles apart, and they travel towards each other, one train travels 30 miles per hour slower than the other. So I'll say one train travels R miles per hour and the other R minus 30. But we're still going to set the distances, we're still going to add the distances and see that they equal 200. So the faster train travels R miles per hour, the slower train travels R minus 30, and they both travel for 2 hours, and they end up 200 miles apart. So multiplying across, we have our distances. And we are going to add our distances and set it equal to 200. So 2 times r minus 30 plus 2r equals 200. So we can solve this equation. And we're getting 65 miles per hour, and that's the faster train. And 65 minus 30 is 35 miles per hour for the slower train. Okay. The next type of problem that we have is when we're traveling to and from a destination. To solve these problems, we're going to use one equation, and we're going to set the distances equal to each other. So my example is a man travels from home to the mountains, and then he's going to travel back home. So due to traffic, it takes 3 hours to get there, but only 2 hours to return home. And he's able to drive 20 miles per hour faster on the way home. So how far does he live from the mountain? So often with this problem, they're not asking for the rates, they're asking how far he lives from the mountains. So my final answer is going to be the distance. So again, rate times time is equal to distance for my chart. And we will look at driving to the mountains and then back home. So we said due to traffic, it takes 3 hours to get there. So that's my time. And only 2 hours to return home. And he drives 20 miles an hour faster on the way home. So my rate is R, and this rate is R plus 20. We're multiplying across, so R times 3 is 3R. And here I have 2 times the quantity, R plus 20. Now what we know is when we drive to the mountains and we drive back home, the distances are the same. So I'm going to take this distance and set it equal to this distance. So 3R equals 2 times the quantity, R plus 20. So 3R equals 2R plus 40. And subtracting 2R from both sides, R equals 40. So my rate is 40 miles per hour driving to the mountains. 40 plus 20, I'm able to drive 60 miles per hour on the way home. But the question asks, how far does he live from the mountains? So that's the distance column. So 3 times R is 120. And coming back home, it's also going to be 120 because the distances are the same. So the answer to that problem is 120. Okay, and the final type of problem that I'm going to show you are going to call the with and against the problems. So you're talking about an airplane that flies with the wind or against the wind, or a boat that travels with the current and against the current. So we're always going to be looking for the rate when we're going with the wind or with the current, and we'll look at the rate when we go against it. So in my example, we have a jet plane. And against the wind, the jet can travel 5,600 miles in 7 hours. And with the wind, that same jet can travel 6,600 miles in 6 hours. So we want to know the rate of the jet in still air. So what is the rate of the airplane if it's not windy outside? And what's the wind speed? So we're going to set this up where we travel with the wind and against the wind. Okay, so we'll have our rate times time equals distance. So the jet travels our miles per hour if it's not windy. But if it's windy, we can make the airplane go faster. When it flies with the wind, the rate of the airplane plus the wind speed will be considered. And when it goes against the wind slows us down, so we subtract the wind speed. And so let's look at time. So going against the wind, it takes 7 hours to go 5,600 miles. And to go with the wind, it takes 6 hours to go 6,600 miles. So we want to know what is the rate that this airplane would have been traveling if it weren't windy in still air, and what is the wind speed that will make this happen. So I have 2 equations. My first, 6 times the quantity R plus W equals 6,600. And my second, 7 times the quantity R minus W equals 5,600. Now I could distribute here to begin, but I see that I can take a shortcut and I can divide both sides of this first equation by 6. And that's going to give me R plus W is equal to 1,100. And my second equation, if I divide both sides by 7, then R minus W equals 800. And so I'm going to solve this system of equation by elimination. If I add these 2 equations together, 2R equals 1,900. And so R is going to equal 950. So 950 miles an hour is going to be the speed of this jet. And if I take it back here, R plus W equals 1,100. So if 950 plus the wind speed equals 1,100, I can subtract 950, and my wind speed is 150 miles per hour. Now you can check that by plugging in here. R is 950 plus 150 times 6 should equal 6,600. 950 minus 150 times 7 should equal 5,600.